Hello everyone, this is Orhan Erdem again. In this video, I will continue our discussion about bonds and show you how to value them. Let's start with essential features of a bond. I will use a timeline to show you what these features mean. So this is a timeline. This is time 0, which means now 1, 2, 3. So these are the periods up to the end, which is the last period, last time. So the first one is a principal. Principal is a par value. The other name of principal is par value or face value. So this is the amount of capital the borrower must repay at maturity. So at the end of the bond period, you receive $1,000. And then you receive a couple of coupons, which I will mention you in a moment. Coupons every single period. So these are the C's, which means the coupons every single period, plus at time N, you receive a coupon. The bondholder receives a coupon. So the coupon rates are determined. The coupons are determined by coupon rate. So whatever the coupon rate say, if it's 6%, if is an example, and if the coupon rate is 6%, so you multiply the par value by 6%, and you receive and you get $60. So this is the $60, and this is the coupon rate, 6%. The amount, the monetary amount. This is the coupon. So the holder receives C dollars every single period plus $1,000 at the end. And the maturity date, last thing is the maturity date. Maturity date is the last date of the bond. It is the date when bond matures, maturity date. Okay, we already talked about what a coupon rate is. The coupon rate is the coupon divided by par value. So in our previous example, it was $60 divided by 1,000. Which gave us 6%. Then the other definition is the current yield. Current yield is the coupon, annual coupon, which is $60 in this example, divided by the bond price. But currently, we don't know the price of this bond. Like whatever the price is, we are going to divide $60 by the price. In the next example, I will explain this better. Suppose a $1,000 par value bond paying $80 coupon. So this is the coupon. Has a price of $1,032.25. So it asks us two things, the current yield and the coupon rate. As you remember, the coupon rate is the coupon, which is $80, divided by the par value. So it is 8%. The current yield is the coupon, which is $80, divided by the price. But price is not $1,000. Price is $1,032.25. When you divide this, you will get roughly 7.7%. So we are done with this part of the question. So it says, what if the price changes to $969.75? The coupon rate does not change, it's still 8%. But the current yield changes to $80 divided by now new price, which is $969.75, which is 8.2%. So as you can see, when the price is higher than the par value, the current yield is lower than the coupon rate. When the price is lower than par value, the current is higher than the coupon rate. So whenever there is a change in the bond's price, the coupon rate remains constant, but the current yield changes. Now let's make the things a little bit scientific. So this is the timeline I used a moment ago. Every period, the holder receives a coupon, which is represented by CF here. It means cash flow 1, cash flow 2, etc., cash flow n. So the value of bond is equal to the present value of all future cash flow, the present value of first cash flow, the present value of second cash flow, etc., the present value of end cash flow. So as a rule of thumb, for all financial instruments, the value of any financial instrument is defined as the present value of all future cash flow. So you have to take the present value of first one, take the present value of second one, and you should add up all the numbers. Now, let's take a look at an example. This example asks us to calculate the value of a 10-year bond with 10% annual coupon, and the interest rate is also 10%. So here is the timeline of this bond. 10% annual coupon means $100 of coupon. So you are supposed to multiply the par value by 10% coupon rate you get to get the coupon payment. So this $100 is the coupon payment. So which means every single year, the holder of the bond will receive $100 plus the $1,000 par value at the end. So these are the coupons. This is the par value. This is the interest rate, and we are asked to calculate the value of the bond. Okay. The first thing is, the first way to calculate the value is take the present value one by one. Okay. The first cash flow divided by 1 plus interest rate to the power 1. Second cash flow divided by 1 plus interest rate to the power 2, etc. And the last payment, which is $100 and $1,000, divided by 1 plus 10% to the power 10. If you add all those numbers up, you will get $1,000. The other way is to use the PV function in Excel. When you open an Excel sheet, click any cell and write equal PV. So, and then open the parentheses. This is a built-in command in Excel which calculates the present value of a stream of cash flows. It asks you four main things. The first one is the interest rate. Second one is number of periods. PMT is the periodic payments. And then the last thing is future value. You do not need to deal with the type. Okay, so let's write them one by one. So the rate, the interest rate is 10%, comma, number of periods. So it's a 10-year bond. And the PMT. PMT is the periodic payments in this question. So we have $100 of periodic payment. These are the coupons. And the last one is future value, which is the payment the holder of bond will receive at the end. It's $1,000. When you write everything, you should close the parentheses. When you hit enter, you will get $1,000. So once again, just to remind you, a red number in parentheses means a negative payment. So this is the payment you are supposed to make in the beginning to receive these $100,000 at the end. So the answer to this question is $1,000. In the next question, we will play with the interest rate. We will increase it and decrease it. In this question, the only difference is the interest rate is not 10%, it's 11% now. So what we are supposed to do is insert all these values in Excel and then come up with a price. Now let's open the same Excel sheet and then use the PV function. PV, open the parentheses. The rate is not 10%, it's now 11%. 11%, comma, number of years, number of periods is 10. Payments is again 100,000, it didn't change. And then the future value, which is the par value, is $1,000. Just the only difference with the first question is the interest rate is not 10%, it's 11% right now. So when the interest rate went up, the price went down. The second question asks the same thing with the interest rate of 7%. So again, the PV function, open the parentheses, the rate is 7%, and the number of periods is 10, PMT is 100, future value is 1,000, close the parentheses, the price went up. So interest rate was 10% here, 11% here, and 7% here. So as a rule of thumb, when the interest rate increases from 10% to 11%, the price decreases. So when interest rate increases, the price decreases. Okay. So when the interest rate decreased from 10% to 7%, now the price increased. When the interest rate decreased from 10% to 7%, now the price increased. So again, as a rule of thumb, when interest rate decreased, the price increased. So just keep this in mind. These are the answers together. Now we have another concept, which is yield to maturity. Let's define this and then solve a question about that. So the yield to maturity is the rate of return on a bond held until maturity. It's basically the return the holder is making on the bond. Let's take a look at this question, which might clarify yield to maturity. So there's a 10-year bond, 9% annual coupon, $100 par value, selling for $887. Let's first define the timeline and put everything here. So it's a 10-year bond, 0, 1, 2, 3, 4, 5, 10. And then its par value is $1,000. And then 9% annual coupon, which means every single period, the bondholder will receive $90, which is 9% of the bond, which is 9% of the par value. The only thing different from the previous question is we have price here, which I will write in red, $887. So this is something the bondholder is paying. The others are the amount bondholder is receiving. Basically, as you can understand, in terms of Excel, we know the PV. So this is PV in Excel. This is FV in Excel. These are PMT in Excel. And this is the number of periods. As you can see, the only thing we don't know is the rate function. So it's the interest rate we are making on the bond. So what we are supposed to do is to open an Excel sheet again. The question is basically asking the interest rate which equates the present value of the right-hand side to the left-hand side. So the present value of all these cash flows must be equal to $887. So what is the interest rate that equates this equation? Which might be very difficult to solve using calculus. So we are going to use Excel. So let's open an Excel sheet and use the rate function. Equal rate, open the parenthesis, and okay, the first thing it's asking is number of periods, 10 years, PMT is $90, present value is $887. It must be with a negative sign just because it's something that the bondholder is paying. The future value is $1,000, it's positive. Please pay attention to two things. The first one is the future value is positive and the coupons are positive, but this one is negative, just because this is the price the bondholder is paying. So when you hit enter, you'll get 10.91%. Please make sure that you have two decimals here. So you might have 11% if you don't have, when you right click the cell, if the decimal places should be 2. Otherwise you might get 11%. So basically 10.91% is the interest rate, which equates the right-hand side of the equation to the left-hand side. Or in other terms, this is the interest rate the bondholder is making. It's called yield to maturity. Bonds are given names according to the relationship between the bond selling price and its par value. So the first one is premium bonds. If the coupon rate is higher than yield to maturity, then the price of the bond is going to be higher than the face value. So let's remember our example. Remember there was a coupon rate of 10% and yield to maturity was 7% in the previous example. And we calculated the price of the bond as $1,210 and the face value was $1,000. We did another example with the coupon rate is again 10%. This time I increased the yield to maturity to 11%, and then this time the price of the bond became $941, face value still being $1,000. Once again, if the yield to maturity, the interest rate of the bond goes up, the price goes down. If the yield to maturity goes down below the coupon rate, then the price goes up. When the price of the bond is higher than the face value, this is called a premium bond. When the price of the bond is less than the face value of the bond, then it's a discount bond. If they are equal, this is called a par bond. In the previous question, let's go back to the previous question, the price of the bond was $887. So the price is below the par value. Okay, par value was $1,000, price $887. So this bond, which we calculated the yield to maturity as 10.91, is a discount bond. The price is lower than the face value, so this is a discount bond. Let's take a look at this question. Melinda just invested in outstanding bond with 5% coupon. So this is 5% coupon. And the remaining time to maturity 10 years. So this is a bond of 10 years, again, 0, 1, 2, 3, etc. to 10. And then the par value is $1,000. So this is par value $1,000. Again, it's 5% coupon, which means that the coupon payments are $50, 5% of the par value, $50 every single year, including the last year. So it's a 10-year bond, par value $1,000, and the market interest rate is currently 7%. So market interest rate is 7%. Let's write it here. How much did Melinda pay for the bond? Is the par premium of discount bond. So the question is basically asking the price of the bond and the type of the bond. To answer this question, let's open an Excel sheet and put everything in place. So I'm going to use the PV function again, the present value. The rate is 7%, so this is yield to maturity 7%. Number of periods, 10 periods, and PMTs are $50, future value is $1,000, close the parentheses, you'll get $859.53 as the price, so this is the price. So this is lower than the par value. Par value is $1,000, as you can see from here. So this is a discount bond. Once again, the price of the bond is $859.53, and it's a discount bond just because the price of the bond is lower than the par value. Even though the PV function is more than enough for bond price calculations, there is another function, price, which might be of some use in some cases, especially we have specific dates like January 1st, April 15th, etc. Let's take a look at this question. Let's take a look at this question to understand how useful it is. So there's a treasury bond traded on March 30, 2020 and matures in 20 years on March 30, 2040. Assuming a 4% coupon rate and 3% yield to maturity, what is the price of this bond? So this bond is traded on this day, and this is the maturity date. There are specific dates. So I'm going to use these dates in price function. In price function, we are using the specific dates instead of like 10 years. Okay, so I wrote these dates here in the yellow cells. All the inputs are given in yellow cells, and I'm going to use them in price function. So write price here, and then the first thing it asks is the settlement date. Click the settlement date in cell B5, and then maturity date is in cell B6, and then it asks the rate. Be very careful, the rate refers to coupon rate in price function, so I'm going to choose coupon rate, which is 4%, and YLD is the yield, the interest rate, which is 3% here. And then it asks the redemption. So redemption is the percentage of the face value. We are so we are going to write here 100%. 100% of the face value is needed, and then frequency is 1, and then the actual 365 days. We are going to use the actual 365 days and close the parentheses. Once again, let me remind you, this is the price of a bond with $100 face value. That's why I wrote here per $100 face value. If you are wondering the price for $1,000 face value, then you should multiply this price by 10. So you'll get the same thing for $1,000 face value. We can get the same exact thing with PV command. So general PV command, we use $1,000 as a convention. Let me use that first. So PV, the first thing it asks the rate. Again, now I'm warning you once again. The rate in price function refers the coupon rate. The rate in PV function refers the interest rate. So I'm going to select the interest rate here, 3%. And then number of periods is, there are 20 years in between, so this is an annual bond, therefore the 20 payments. And PMT, PMT is the period of payment, coupon payment. As the coupon is 4% here, 4% of $1,000 is $40. So I'm going to use $40 as a PMT here. And then last thing is future value, it's going to be $1,000. And then you hit enter, you'll get the same exact thing. It's minus because you are going to pay it, that's why. And then you can do the same exact thing here, PV function with all the same inputs. This is rate, number of periods is 20. PMT, the only difference is the PMT. If we are using $100 as the face value, the PMT must be 4. Face value, the future value is going to be 100. And you are going to get the same exact thing with the price function and PV function. Now let's talk about a couple of other features of a bond. This time about the prices. Prices of all types of bonds are usually expressed as a percentage of par. So there are generally two types of conventions. So the first one is related with corporate and municipal markets. In this case, the bond prices are expressed in decimals. For example, quote of 87.562 translate into a price of 87.562% of the par. If the par is $1,000, then price of the bond is going to be $875.62. In U.S. Treasury and Agency, bond quotes are stated in 30 seconds of a point. 1 point equals to $10. A quote of a T-bond, for example, of 94.16 translates into 94 plus 16 over 32, or 94.5% of the par. If the par is $1,000, so this means that the price of the bond is going to be $945. Many corporate and municipal bonds contain a call provision that gives the issuer the right to call the bonds for redemption. The call provision generally states that the issuer must pay the bondholders an amount greater than the par value if they are called. The additional sum, which is termed a call premium, is often equal to 1-year interest. Let me give you an example. Assume we have a 10-year bond, the 10% annual coupon and par value of $1,000. assume the issuer wants to close the bond here. This means that he's not going to pay any of those coupons at all in the future by paying a little penalty. So he pays the principal, which is $1,000, plus a premium. This premium mostly equals to 1 year's interest. For example, in this scenario, it's going to be $100, but it's not always the case. In most cases, the provisions in the bond contract are set so that the call premium declines over time. But anyways, under this scenario, the issuer already paid the first coupon, already paid the second coupon. So he's going to pay the third coupon plus the principal with a fee, which is $1,100, and he closes the bond, and he is not going to pay anything at all from that time on. This happens mostly when the interest rates goes down. When this bond was issued, the interest rate was around like 10%. When the interest rate goes down, say to 5%, the borrower issues another bond with a 5% coupon. Like instead of $100, he's going to pay $50 in the future. So that's why, once again, the call provision, the call happens mostly when the interest rate goes down. Some bonds are freely callable, some bonds are non-callable. In some cases, bonds are often not callable until several years after the issue, generally 5 to 10 years. This is known as a deferred call. Call features work for the benefit of the issuer, as I told. Call features work for the benefit of the issuer, allowing the issuers to take advantage of declining interest rate in the market. The investor is left with a much lower rate of return than would be the case if the bond was not called. Now let's talk about semi-annual bonds. Although some bonds pay interest annually, the vast majority actually make payments semi-annually. To evaluate the semi-annual bonds, we must modify the valuation model. To do this, we have to multiply the years by 2, and then we have to divide nominal rate by 2, divide the annual coupon rate by 2. Well, let's take a look at this example to clarify the things. What's the value of 10-year, 10% semi-annual bond if the interest rate is 10%? In this case, the time value, the timeline of the bond is going to be something like this. So times 0. So we are going to have 2 payments per year. So this is the first 6 months, this is the second 6 months, this is the third 6 months, this is the fourth 6 months. So in reality, we have 10 years and 20 payments, because every year there will be 2 payments. And instead of receiving $100 per year, the bondholder is going to receive $50 per 6 months. So that's why we are going to multiply the years by 2. We are going to have 20 periods, and then nominal rate by 2. The interest rate is going to be 5%. Annual coupon is going to be $50. So we are going to use this PV function in Excel again, with the interest rate being 5%, a number of years being 20, and coupon being 50, and then par value is going to be constant. When we do this in Excel, we will get the following. Enter $1,000 again. So the price of this bond is going to be $1,000. So what if the interest rate is 13%? Now we are going to do the same calculation. Instead of 5%, we are going to use half of 13%, which is 6.5%. So PV, open parenthesis, 6.5%, number of periods is going to be 20, PMTs are going to be $50, and the future value is going to be $1,000. When you hit enter, the price went down, as you can guess. Remember, we already talked about this. If interest rates go up, the prices go down. So as a result, the price of this bond is going to be $834.72. Now let's take a look at this question, which requires to use price function. I'm going to solve the question using both commands, price and PV. So there is a bond traded on March 30, 2020, matures in 20 years, March 30, 2040. I enter these dates in the yellow cells here. Our settlement date, maturity date is 2040. It's 20 years bond, and then the coupon rate is 4% and 3% yield to maturity. I entered everything in the yellow cells just to use it in the command. So let's start with the price command right here, price, and then enter the settlement date first, comma, I'm going to enter the maturity date, 2040. The third input is rate. Be very careful in the price function. Rate refers to coupon rate. So select the coupon rate as 4%. and yield to maturity as 3%. Redemption is always 100. Frequency is, this is a semi-annual bond. I am going to select the second option as semi-annual payment. And then the last thing is number of days. So I'm going to select 365, which is the option 3. And then you close the parentheses, you will get the price per $100 face value. If the face value is $100, this is the answer. This is the price of that bond. If it is $1,000, then you are supposed to multiply this, the price of this bond, by 10. You'll get the answer. Now let's solve the same thing with PV command. In PV command, you are supposed to do a couple of calculations while entering the inputs. Let's write PV function. So again, the same rate function that I warned you before. Be very careful. In PV function, rate refers to yield to maturity, the discount rate, okay, which is 3%. But since this is a semi-annual bond, we are supposed to divide it by 2 and then comma number of periods. So number of periods is 20 years multiplied by 2, just because every 6 months the investor is going to receive a coupon. So there are 40 periods. And PMT. PMT is the periodic payment. So the coupon rate is 4%. If we are talking about $100 face value, so this is going to be $4 per year, but it's going to be paid $2 per 6 months. So the PMT is going to be $2 every 6 months, comma, the future value is $100. So this is going to be the price of that bond. It's negative just because it means that the investor is going to pay it. Let's do the same thing with $1,000 PV function. The rate is going to be, again, the interest rate, the yield to maturity divided by 2. Number of periods is again 40. PMT is, this time it's not $2, it's $20, as the face value is going to be 1,000. When you close the parentheses, you'll get the same answer with the price command. This is all about the valuation of the bonds. I hope you enjoyed the video. In the next video, I will talk about the risks associated with the bonds.